Here we see the dimensional metrology data form. It includes student name, section, there's 6 different sections, instrument, measurement component, pump shaft and conveyor bracket components, part serial number, measurement value, and measurement units, metric or customary. We can see that this form has some submissions already, and we can get a little bit of a analysis of some of the data. There's 2,673 submissions, about equally across different sections, mostly with vernier calipers. Different measurement components are also equally represented, as well as part serial numbers. Different measurement values here, and then different units. The predominant unit is metric as opposed to US customary. So this data is available in a spreadsheet, and so that spreadsheet looks something like this, where we have timestamp, the email address or user ID of the submitter, the name is hidden here, section number, instrument, measurement component, the measurement value, part serial number, and measurement units. Now we're trying to do basic descriptive statistics, things like count, mean, median, mode, population variance, standard deviation, max, min, and range. And so those are relatively easy to do in a tool like Google Sheets or Microsoft Excel using pivot tables. And so we'll go ahead and take a look at that right now. We'll select our data, and then we'll do insert and table. Actually, not insert table. We will insert pivot table, slightly different. It's going to default to all of the data. It's going to make a new sheet, and that new sheet is shown down here. Now we just need to tell it how to slice and dice the data. So one of the things we want is on the rows, we want the different measurement components. And so we see here that we have conveyor bracket dimensions, pump shaft dimensions. We can take off the totals. And then in the values, we want things like the count, the number of each of those values. So if we do measurement component and we add count here, count A or just count. Count A is for if there's a text, a unique text value that's counted. And so the empties are here, the blanks, and then we have about 146, 147, 140s of each of the different measurement components represented. So we do want to filter on one of the key things here is section. So we really only want one section data represented as a population. So we're going to take just section 10 as an example. And so we see the numbers get down a little smaller when we look at just one section for our filter. About 30 for each measurement, and there's a couple extra measurements in here that have a smaller number than, and those measurements weren't required to be taken. So if we want to actually get to computing values, we'll take our measurement numerical value, and the default statistic is going to be sum. So we want to first look at the average, and we can see the average here. It's a little easier if we change the formatting to just show 2 decimal places here, and so we can go ahead and see our average. Now that average is based on the fact that it's not intelligent on whether or not there's a different set of units for each one. So we actually need to do a little bit of unit conversion before we actually do the statistical analysis of this data. So what we're going to do is we're going to go back to the forms responses, and we're going to add a column here that's just measurement value in millimeters, and we're going to copy this cell right here. Then we're going to make a little conditional if statement. It equals if this value equals double quotes US customary inches, close quotes, then we're going to convert the numerical value by multiplying by 25.4 to get from inches to millimeters, or if it's already a metric, we'll just keep the value there. And so that's our conversion equation. It'll ask us if we want to fill that. We can just check that box, and now we have filled data in millimeters for all of our table here. So we go back to here, and we'll change our data table a little bit to add that extra column in. And then where we have measurement component picked here, we're going to remove that, and we're going to add the value, measurement value in millimeters. And actually, we don't want to add that as a row. We want to add that as a value right here. So we'll add measurement value and then we'll add the average, shown right here. We'll add in the measurement value variance of the population. We'll add in measurement value standard deviation of the population. Add in measurement value and the next thing we want is the maximum. So the maximum, and add another one for the min. Now we can't get the range in here, so we'll have to compute that later, but we can get the median, and so we'll look at the median. Okay, so notice that we don't have range or mode in here, so we'll have to do that after the fact later. We're filtered on section 10, and we've got all of our statistics here, so we'll just close this out and take a look at our data, and here we go. So we can take this data, we can change decimal places, we can center it all up, and now we have clean looking data. We'll go ahead and change, shorten some of these headers so that they're a little bit more readable. So we'll take that one, we'll get rid of the measurement value, so it's just stating the min, the max, standard deviation of the population, variance of the population, and then the average. Okay, we can shorten count just to be count. So now we have our basic descriptive statistics shown here. There's a couple more that we were asked to compute. One is range, so that's pretty simple. We'll also put units in that. So we'll just do equals max of this guy. So actually we'll just use this equation, equals this guy minus this guy, and we can fill that down, and now we get all of our ranges as well here. Okay, if we want, we can fill that in, make it look a little closer to the existing format. Not quite right, but similar to that, maybe like that. And then now we have everything but mode. Sometimes we like to compute coefficient of variation, but let's look at mode, for example. So mode is the most common value, and so it's not available in pivot table. So to get this, we'd really need to come back and do a little bit more data manipulation here. So if we wanted to do that, first thing I'd probably do is start with a filter, and for the filter we'll just take section 10 data. Okay, and then here let's just look at conveyor bracket data OA for starters. And so with this we could add in mode, and the mode function is just simply the mode. We'll use the metric values, and away we go. So we see that the mode is 35, which is the most common value within here, which is actually the measurement specification, I believe. So we could take that and we could put that back over to here, 35, and then we could do the same thing if we wanted to do it for all the others in less of an automated way. So let's take this guy out, and we'll click that guy and keep that guy. Now we'll do this again, B and not that one. Okay, and so must not be saving that down here. Yeah, there we go. Okay, so now I'd have to do that again, equals mode, and we'll use the metric, and so that's 47. So a little bit of a manual process to do mode. So we'd prefer to have a way of doing that programmatically, more efficiently, but that's what it is right now in Google Sheets. So those are the basic statistics that we're after for problem 4.21, which is basic descriptive statistics for our measurement application.